Hello, and welcome to the AI HDL Design Phase 2 demo. Today, we are going to explore the features that you can implement in your digital watch project. This is an exciting opportunity to apply your Verilog skills in designing a hardware-based digital watch. The project covers a range of features, from basic timekeeping to advanced functionalities like alarm clocks, time format selection, and handling different time zones. Let's take a look at some of the key features that you can include to make your digital watch functional, efficient, and user-friendly. As a disclaimer, all code shown in these demos is not perfect. Prompt engineering is an iterative process. A single prompt will most likely not give code that works on the first try. These demos are meant to give you a starting point from where you can begin working on your project. Copying code from them is not guaranteed to give you a functional design. The digital clock module is a foundational component for our design, providing basic timekeeping functionality by outputting hours, minutes, and seconds to the top-level system. This initial implementation serves as a basic module, which we can later enhance using GPT to add features like time zone support and dynamic time adjustments through buttons or switches on the FPGA. Your goal is to refine this code to fit seamlessly within your design, ensuring it integrates well with other components while allowing future customization for more advanced functionalities. Building on our initial clock module, we now introduce support for multiple time zones by modifying the clock to include an array of hard-coded time zone offsets. These offsets, representing hours, can be selected dynamically using a time zone select signal, allowing the clock to output time for specific regions. As shown in the example, GPT-generated code demonstrates how these offsets can be integrated, providing a flexible way to program time zone specific outputs. This enhancement highlights the iterative process of expanding the clock's functionality, setting the stage for even more user customizable features. We will now use ChatGPT to generate our digital clock module in Verilog. After prompting, you can see that ChatGPT has returned us a file containing the code as well as an explanation of the inputs, outputs, and logic. Now, ChatGPT is not perfect. It will most likely take several prompts in order to get code that you are happy with. However, once you are happy with your code, you can prompt ChatGPT to add support for multiple time zones. Here, we ask it to use hard-coded offsets for each time zone. In the code, you can see the changes that were made in order to accommodate this request. Now, once you have the code, you can copy it, go to Vivado, go to Add Sources, add or create design sources, create file, and name this file clock_time zone. Press OK, finish, OK, and yes. This will create a file under the design tree in the Sources tab. Once the file is created, you can double-click on it to open it up in the text editor and paste all your code into it. We now have our completed digital clock module with time zone support added. We now introduce a module to toggle between 12-hour and 24-hour clock formats, adding flexibility with a simple button press. This module uses a binary signal to track AM or PM for the 12-hour format, ensuring accurate time conversion. The ChatGPT prompt demonstrates how to convert a 12-hour input into a 24-hour output, enhancing customization for the digital watch design. We will now generate our 12 to 24-hour conversion module. Press Add Sources, add or create design sources, create file, and for the file name, we will be using Convert 12 to 24. Press OK, finish, OK, and yes. Now that we have generated our file, you will see it appear under the design sources. We can double-click on it to open it. Now, to get our code, we will go to ChatGPT and we will prompt ChatGPT to generate our code for us. After generating, you will see that ChatGPT has returned us a description of the inputs and outputs, the code itself, as well as an explanation for how the code functions. Now, If we go back up and press copy code, we can go back into Vivado and paste the code into our module. This completes our module for converting from a 12-hour format to a 24-hour format. Our final module adds an alarm clock that triggers an LED to blink when the clock matches a user set time. Using 3 buttons, users can set hours and minutes for the alarm. This module integrates with the digital clock output, providing a user-friendly and functional feature for our digital watch design. To generate our alarm module, we will first go to Add Sources, Add or Create Design Sources, Create File, and we'll name the file Alarm. Press OK, Finish, OK, and Yes. This will create our alarm module underneath the Design Sources tree. After double-clicking on it, you will see there is nothing in there. We must prompt ChatGPT to make our code for us. As you can see, after prompting, it gives a short description of what the code does, as well as the code itself. It also gives us a list of the different features the code has and any assumptions it may have made. Now, if we go back to the code, we can press the Copy Code button. Going back to Vivado, we can paste this code into our alarm module. This completes the alarm module for our digital watch. With all our modules generated, it's time to update the top-level design. This design integrates the clock, 12-24-hour converter, alarm, and stopwatch modules. To switch between modules, we use a state machine, controlled by button 0 to track and change the active module. This will ensure that we have complete control over which module is being actively used. We will now update our top-level design. As you can see, under Design Sources, none of our new modules fall under the top-level design. This is because the top-level design does not call them. If we go to ChatGPT, we can prompt ChatGPT to update our top-level design with a state machine and all the modules we have made. Afterwards, it will give a description on what it has done to the top-level design, as well as a file to download. If we take the code in this file and paste it into our current top-level design, we will see that our modules now fall under the top-level design. This is because the modules are now being called within our top level. To wrap things up, we have covered some of the exciting features you can implement in your digital watch project, including the alarm clock, 12 24-hour time formats, and support for different time zones. These features will not only make your watch functional, but also introduce you to some important concepts like state machines, time counters, and user interfaces. We encourage you to think about how each of these features works together and how you can extend your design even further. As you start generating your Verilog code, keep in mind that these features require careful timing and logic. Above all though, have fun with your project, and we are sure you will end up with a fantastic digital watch design. Want to learn more? Well, we've got you covered. Visit our website for more information on how hardware is designed and tested for real-world applications. We would like to give a big thanks to our sponsors as well as all participating universities.